so let's dig in a little bit more to rope life, myth versus reality. And I'd like to hear from you guys if rope life should ever be spec'd in numbers of years.
You're bringing me into the topic. So, as I said before, the rope life is a finite number, okay? And rope life is based on number of bands. So we cannot measure the lifetime in number of years, but in number of trips. And based on the number of trips, it depends if it is one-to-one reeving, direct reeving, two-to-one reeving, reverse bending, or how much complicated is the reeving arrangement. So it depends on the configuration again. I agree with Greg Nicola when he said that everything starts into the design. So if the design is well made, well managed, then the lifetime of the rope will be further explored and obtained. So basically, the number of trips is really the key factor to define the lifetime of ropes. There are formulas developed, for example, by Professor Firer that are helping you to define how many bendings the ropes can live with based on the configurations. And this is something that can be spec'd at the beginning and referred to. So this is just to give an overview on the topic, and then installation and equal tensioning and so on.
That's great feedback. Any challengers?
Can we blame the maintenance company? Or wait, it's too early for that. Sorry. Yeah, you're right. But the one thing I think that you're leaving out is the environment also. The environment of the location of the building. Like, look around us here outside. Is the building protected? Machinery is protected. I've had doors open in machine rooms, and what does that do? Right, go out maybe a little bit further out in Long Island, out in the Brooklyn part, and then you get the sea air. So I think the environment has to do with that also, and then the shifts too. We can't leave you out, the shifts.
So let's talk about shifts too. Let's think about the fact that equipment that was installed 80 years ago, much larger, more robust machines with much larger shifts. In today's climate, when things are going smaller and more aggressive, are we as an industry overselling longevity?
I think that's me.
Go for it.
No, I don't think we're overselling longevity. Again, I just think the expectation that a machine with a 16-inch drive sheave that's hardened with V-grooves that's expected to deliver the same traction that a 36-inch sheave that's, got, 160 degrees of wrap, it's apples and oranges. Again, we're asking for a technical solution, and the machine is operating as it should, but if the expectation is that you're going to get 20 years of life, then someone hasn't managed building ownership expectations properly. So, yeah, I'm definitely a proponent for larger sheaves. I'm gonna hammer away at that all day, but I believe that modern equipment performs as it's spec'd to, but the expectation doesn't match that.
Yeah, I'm going to jump in there. I agree, actually. I think a lot of the theme here is going to be managing expectations from the customer, for the end user, for their developer. I think that sometimes we, as an industry, tell the end user and the developers what they want to hear, as opposed to what the new reality is. The machines of 50 and 60 years ago are not the machines of today, and that old adage of things aren't built like they used to be there is some truth to that. And I think it just comes down to kind of managing those expectations better.
I get one more thing. Technology is much different, right? Drives, processor systems. This wasn't on these older machines. Yep. So just a quick little thing on it.
May I add one further layer?
Sure, you may. Go for it.
Because here in North America, you are used to have very big machines and very big sheaves. We are European, we have very small shaft available, and we are getting more and more into small diameter, small traction sheaves, small ropes. The most common used rope in Europe is the 6.5 millimeter. That is very, very thin. I don't know into imperial metric, whatever is the conversion, but you get the feeling. So in that case, we are using special constructions that are typically Warrington, that are more flexible in this respect. And we are testing in laboratory the possible configuration to demonstrate that the lifetime is reasonable for this type of applications. So some design calculation experimentation in laboratory can help to figure out which can be the possible lifetime.
That's very interesting. We'll all stay tuned for that, Nicola.